Did you know that there's hardware switching mechanisms and software switching mechanisms? Well, find out next right here on IT Pro TV.
You're watching IT Pro TV.
That's right. We're going to be taking a look at Cisco Express Forwarding today, and here to help us out to understand what that even is going to be Anthony Sequeira. Anthony, let's talk about this idea of Cisco Express Forwarding and why do we really care? You tell me, at least before the show, that there's kind of a little bit of a history behind this.
Yeah, there sure is. This is part of like the arms race, if you will, in high speed, ways to move traffic. I remember when there was initially the cache-based approach that was invented, and you, I'm sure, taught this long ago, Ronnie, like I did. It was all about, okay, if the device is moving traffic from one port to another for one host to communicate with another host, let's cache that result. So when they go to talk again, that is in a cache and the traffic can be quickly moved with that cached entry. Then someone wisely came along and said, let's pre-build all of that in the hardware. Remember, we want all this information in a hardware ASIC, an application specific, thank you, integrated circuit. We want all of this information in there because it's way faster than doing anything in software. So let's pre-build it. Let's not wait for demand. Let's put everything that we need to move traffic blazingly fast. Let's put it all in a hardware mechanism. And that's what we're going to look at today, Ronnie. In fact, we can even see these mechanisms at the command line.
So if this may be for a CCNA student coming up, they might have heard about the term CEF, but might not have heard that explanation. But that other method that you were talking about, we sometimes refer to that as process switching. Is that correct?
Yes, that's right. So process switching involving a demand-based approach. And the thing that's interesting is we can't always do this Cisco Express forwarding, this really blazingly fast. There are exceptions to that. And the process switching needs to get involved for certain types of traffic. For instance, what if the traffic is destined for that device itself? Well, then it's going to go ahead and do the older school process switching. But the good news is for almost all of the traffic, the through traffic, then this really blazingly fast Cisco Express forwarding is going to take over. And it's important to realize that a lot of us don't even touch this because Cisco Express forwarding is all set up by default on these Cisco devices.
So what are we actually taking a look at then? So now that you've explained it, what else are we actually going to do with it?
Yeah. Let's see what this looks like at the command line, and let's see some of the manipulations that we might end up making. So Ronnie, here I am on the R1 device that we've used with some BGP in Encore. And that means if I do a show IP route, we've got lots of stuff going on in here. We've certainly got our connected interfaces. We've got our OSPF learned information. We've got our BGP learned information. And what we're looking at right now is actually formally called the RIB. This is the routing information base. Kind of think of this as the software version of this routing information. So in Ceph, it's going to look at this RIB information and it's going to use it to populate the fib. Now, when I was growing up, a fib meant a lie. Right. No lies here. We're not lying. The fib is the forwarding information base. So the routing information base is used to construct the forwarding information base. So how do we see that? We know show IP route. We're so accustomed to that. That shows us the RIB. How do we see the fib? Well, that is show IP Ceph, I think. and you don't really ever have to do this. That's why these commands are always tricky for me to remember. And I got lucky. Show IP Ceph does show us the forwarding information base. And you can see, Ronnie, how that's being pre-populated based on that routing information base.
Now, as we go through this, most people may actually be taking a look and going, well, what's the big deal? And it sounds like two different tables. Why is the idea of this fib so important? Is it because the fib actually resides on the ASIC as well?
That's right.
Okay.
So the router is using that fib whenever possible to just be faster. And, this is really great stuff. Now, notice there's directions in here like, okay, if the traffic needs to go to this destination, use this next hop, use this interface. But then you can see things like drop. So it would make drop decisions very, very quickly. Now you might see one in here. You might get lucky when you're looking at the fib and you might see a punt. And when you see the term punt, this doesn't have to do with Super Bowl Sunday or what certain football teams have to do a lot of, punt, unfortunately. But that word, when we're talking about these structures, what it means is it means Ceph can't handle it. Remember, we said there are certain cases where Ceph can't be used, and we have to go to the old school process switching approach, and that's what it does. It punts it to the older mechanisms, which, in all fairness, are still fast. It's just not as fast as Cisco Express Forwarding.
Yeah, this actually sounds like something that's now all the things are starting to click in place, understanding the use of the ASICs, getting everything else in place here. But there's some other tables that we also need to be aware of, right?
Yeah, that's right. We have the fib, which is based on the routing information base. That's the layer 3 information, but we also need layer 2 information. So how is that handled? Well, think about this. We know we can run, what is it, ARP? I think I'm on a Windows machine right now. So if we do a show ARP, yes, this is the required layer 2 information, Ronnie. So we've got our MAC address to IP address mappings in here. This is additional information that the router's going to need. So this is the ARP cache we're looking at. That would be the process switching mechanism. But what about that lightning fast, Cisco Express Forwarding? Well, it uses what's called the adjacency table. So if I do show adjacency detail is our command here, we'll see the lightning fast information that's in the adjacency table, and it's the ARP table that helps populate this information. So
Yeah.
really, Ronnie, when you talk about Ceph, you're talking about the forwarding information base and the adjacency table working together to give this system all it needs to forward traffic blazingly fast.
Now, before we move on, because you just went through a ton of concepts, let's make sure that we get this right. So the rib helps us to populate the fib.
You got it.
So that actually is that way. And now we're actually saying that the ARP table also helps us to populate the adjacency table as well.
You got it.
So we actually are working on layer 3 and layer 2, which is what we have to do in networking.
That's right. The device needs that MAC address information. It needs that prefix information. So we're providing it in the hardware ASIC with everything it needs. And we're using the old school routing table and the ARP cache to do that.
All right, now I've done this before, Anthony, because people start having questions as they start doing their own study. And I've had to kind of gloss over it. I've used the term CAM table before and TCAM, and in CCA when I've taught this, and of course I was like, look, we do need to get to it, but more than likely at the CCNP level, not at the CCNA. So I kind of pushed it off because I know that it can get very detailed. Why don't you help us out there a little bit?
Yeah, we're on a router right now, and we know, we've just covered the primary mechanisms of the software approach and the hardware approach. Great. Now let's move over to a switch. When we move over to a switch, there's something that over there that's really interesting to talk about. And by the way, notice that those commands were tough for me to remember in the router because we don't really have to use them much. There are these corner cases where Ceph is freaking out and causing a problem, but I've got to admit, I've never seen it in production. I've never seen it in a practice lab. It is so rare that you would mess with this stuff. Now, when we come over to the switch, we're going to see that there is an opportunity for a little bit of configuration here, and I'm going to show you that. But let me back up to Ronnie's point. So here we are in, by the way, your hands-on lab environment. So it's just great. Ronnie and I have been using Cisco's Viral for a lot of the demonstrations in Encore because we have a Viral license, but it's so great that you have gear right in the IT Pro TV library for you that you can jump on. So this is a real device, just like the Viral's a real operating system, but this is a device inside of the practice labs. And let's just actually do a quick show ver so we can see what device we're working with here. So this is a nice 3750 from Cisco. And when we do a show, what is it? Show Mac. Oh, it varies.
Dash table. Yep.
Is it?
Address dash table.
Yeah. Why isn't it liking that? Let's see.
No dash in between the Mac and
Ah,
address.
thank you. It varies from device to device. Yeah, it drives you nuts. So there's the MAC address table. So that's the CAM table, the content addressable memory, but there's a faster mechanism, and that's the TCAM. The TCAM, that faster mechanism, it's tertiary, something.
Henry. Yep.
Yeah. So is it ternary?
Ternary.
Yeah. I just always call it the TCAM, right? So the TCAM is that faster mechanism for doing that switching decision. And this is where we can get into a little bit of configuration. Your switch is going to be set with some limits on the TCAM, and you want to use this command, the show SDM prefer command, to see what template is in use for the TCAM, for its like max values. So look at this. This is so interesting. I do a show SDM prefer, and it says you're currently in the desktop default template. So this switch is tuned for just the normal operation of getting all these desktops onto the network. And it says, okay, you can see the constraints, the maximum values here that are set on this device. So the maximum number of unicast MAC addresses is 6,000. Whoa, should be more than enough. But notice, like with IPv4 policy-based routing ACEs or access control entries, there's been no reservation for that. It's like, well, that wouldn't be utilized in this type of template for just default desktop access. So what you can do is you can go in global configuration mode, and you could do SDM prefer, I believe. This is another command that we don't have to do that much of. SDM, so I had a typo. SDM prefer, there we go. And my context sensitive help shows me the templates that are on this switch that I could set in order to change the default characteristics of what's possible with the TCAM. This is one of those like CCIE things, right, by the way. So I think I won't get in trouble for this. It was like one of my first CCIE attempts where in the switching section, it was something to the effect of tailor your switch so that it's really tuned to do layer 3 routing. And I was just like, yeah, what is it talking about? The CCIE lab exam is the worst place to learn about a feature. You'd kind of like to know about it. And this is what it was talking about. It wanted me to go in and do SDM prefer routing. So now what I just did was I told this device, look, how we're using you in our enterprise is to do a bunch of high-speed routing for us. And that is going to change these values in the template. We will for sure get IPv4 policy-based routing ACEs, and we'll get 500 of them, by the way, when we set this. So I just did set it, and notice it's telling us, all right, in order for that to take effect, you need to do a reload. So I am now reloading that 3750 so that it is up and active for us with that new template. So this is something rarely done, but note, this is a configuration that we would make potentially in order to tune this device for its role in the enterprise. And I would definitely know this.
Now, once we actually do something like this and we reload this, does it add in any extra commands into what we have?
No, that's a great point. So this didn't influence the command set that we're working with. This is just tuning the architecture for the device's role in the enterprise. I wish we had something like this, Ronnie. You know, when we come into IT Pro TV, I wish we could kind of preset, all right, I need to study today. Give me the study template. That would be nice.
Yeah, so while we're actually reloading, why don't we go ahead and do this, to our viewers. It would just look like that we snapped our fingers and it'll be done, but it may take a little bit of time for a device to reload. So what we're going to do is just do that. We're going to do just a very brief timeout, and we'll be right back. Oop. Just like I said, it's just a blink of an eye, but there it is. The router is now actually kind of rebooting at the end here. And Anthony, we are back. So show us that it actually did take place.
Yeah, let's make sure of this. And by the way, that's a very, you're sitting there with much trepidation in the CCIE lab exam anytime you have to reboot one of your devices, right? Make sure you've got your AAA set up correctly, because I could imagine, in fact, this has happened. This has happened. The student has to do something like this. They've messed up their AAA. They reboot the device and they've locked themselves out. Oh. They just failed.
Yeah.
And that proctor is not going to help them get back in. So make sure that doesn't happen to you. For those of you thinking about the CCIE lab exam, look at that, Ronnie. We are now no longer the desktop default. We are the desktop routing template. And we can see that these numbers have changed. So it is tuned now for fewer unicast MAC addresses than before and a ton of routing information. So we're getting the reservations in the TCAM for all this great routing stuff.
Now, before we close out of our episode here, I have one last question. Does this affect the performance of the switch?
It won't to the naked eye. That's a great question, Ronnie. So to the naked eye, it doesn't. But yeah, it is affecting the performance. If we were to go in and really measure the performance of the device, we could see an impact. And that's why we would do it. Hey, tune yourself to routing versus tune yourself to switching.
All right, Anthony, thank you again for helping us to understand those different concepts here. We've been talking about Cisco Express forwarding and some of the different tables and the nature of how those things actually work together. Make sure you review this episode to understand the differences between the fib and the rib, the TCAM and the CAM, and of course the ARP and the adjacency table as well. There's a lot that we went over in this episode, but there is also more to come, so stay tuned for that as well. Signing off for IT Pro TV, I'm your host, Ronnie Wong.
And I'm Anthony Sequeira.
Stay tuned right here for more of your CCNP Encore show.
Thank you for watching IT Pro TV.